Welcome to Chapter 13, Drive Axle and Differential Diagnostics and Service. So, first things first, when we have a customer that brings a car into our shop, the first step in the procedure here is to verify the customer concern. And so, in order to verify the customer concern, you need to keep a few things in mind. If it's a noise-related issue, you could probably drive that vehicle on a test drive on normal road surfaces and reduplicate the customer's concern. If they're complaining of a lockup or like a limited slip issue, you might have to drive that vehicle on a slippery surface in order to force the vehicle into a scenario where the lockup would come on, and in this case maybe it doesn't come on. So we need to identify the vehicle drive axle and the gear ratio. Something that's important to keep in mind is that manufacturers don't necessarily use the exact same axle when we switch between like a four-wheel drive and a two-wheel drive. So you might have a half-ton pickup truck that is two-wheel drive, and a four-wheel drive version of the exact same truck might have a completely different gear ratio. And so in order to service these units, we have to make sure we know exactly what we're working on. And so we need to identify the vehicle drive axle and gear ratios. And one of the ways we're going to do that is by referencing service information, which is my favorite way to do it. So service information is going to allow us to look the vehicle up by VIN number. And the VIN number is going to, hopefully, in most cases, will identify the RPO code. The RPO code is going to list what the manufacturer put on that vehicle from the factory. And so if we are trying to figure out what the differential is and we're not quite sure, we can reference service information. If service information directs us to an RPO code, we can go find this tag either in the glove box, door jamb, something like that. And so the other way we can identify what the differential is just by simply looking at it. And so if you look at page 227, there's a whole bunch of these differential covers that are on this page. Differentials are similar to like transmissions. The pan itself and the cover and the amount of bolts and the shape, that's very unique to one manufacturer's axle. And so if you look at like Ford 8.8, for example, it's kind of like a square, but it's not quite a square. It has rounded off corners, and we can count up how many bolts there are. And we can compare that 8.8 inch to another Ford 8.8 inch that might have a different gear ratio, for example. And there's a slight difference in the case. And so we can visually line those up and determine whether or not we have one or the other. So when you have a car that comes into your shop, most of you are probably going to have the entire vehicle, and you're not going to have just like an axle dropped off. If you're working in a driveline shop, you're working on more specific, like, rebuilding processes, and you're a specialist on differentials and axle rebuilding, transmissions, things like that. You might have customers that just drop off an axle and you don't know what vehicle it came out of necessarily. That's where this would be beneficial. For all the other scenarios, you're going to have a vehicle that comes into the shop with an axle. And so you're going to be able to just look up the VIN number, make, model, etc., and figure out what exactly you have that you're working on. Now, it's important to understand and know exactly what the axle is, because procedures are going to change. So setup procedures, torque specs, but also fluid. And so if a vehicle calls for an 80-90 weight, in one application, and in another application it might call for the same oil, but it might include a special additive package, maybe for a limited slip clutch. And without that additive package, just changing the fluid, you might cause an issue and burn up a limited slip differential because you didn't know that you were supposed to add some sort of friction modifier that was part of the called out in the service information. So when we have a vehicle in the shop, we want to check the vehicle history if possible, and we also want to look up TSBs. Part of identifying the customer's concern is going to be going to the computer and looking up service history and technical service bulletins. And so manufacturers tend to have common trends with certain components failing, and you may have an issue where the customer is complaining of like a chattering noise coming from the rear end of the vehicle. The chattering noise might be originating in the limited slip components, and technical service bulletins might point you to replace the entire limited slip clutch pack rather than take the diagnostics any further. And so The value of technical service bulletins is really, really important to understand when it comes to diagnosing these really odd nuances. Now, true, if you had a vehicle that like completely exploded the differential and you had no forward motion at all, I mean, it's going to be pretty straightforward and obvious. You're going to pop the back cover off and you're going to see gear pieces laying in there. But when you've got these little nuances, maybe like a chatter or a little wheel hop issue, it could, the root cause could be a differential component, but identifying that might require looking at service information and specifically technical service bulletins. You might need to hoist the vehicle up in the air and run it in drive in order to identify where a particular noise is coming from. So let's say it's a pinion bearing versus a outboard axle bearing. You might not be able to pick up on the outboard axle bearing specifically. All you might be able to hear from the driver's seat is a noise coming from the back, and having the vehicle up in the air with the vehicle's wheels engaged and driving while walking around the vehicle, you might be able to then identify where that noise is coming from. So finally, disassembly and inspection of the differential, tearing it down and taking a look at it and looking at individual components is going to give you a visual cue. And if not visually, you'll be able to put special tools like dial indicators on components and check things like backlash, check things like run out on ring gears, etc. Here we go. Checking for proper backlash is going to entail setting a dial indicator up on one of the teeth as illustrated. On the other side, you cannot see it in this photo, but there's a pinion gear that is installed, and the backlash is going to be the play between the gears as illustrated in the illustration right below that picture. And so if the manufacturer calls for, let's say, 10 thousandths backlash, and you go to check it and you see 30 or 40 thousandths, and you've got a customer complaint of a clunk while engaging into drive or engaging into reverse, you might just simply have worn out pinion and ring gears. You might be able to readjust those gears and get the backlash back in line, or you may have to discard those components and replace the entire ring gear and pinion gear setup. Differential lubrication is fairly straightforward. There are no pumps. I should say that in most cases there's not going to be a pump of any kind. We simply have splash lubrication. We call that dynamic lubrication. And so if you take a look at this illustration, the ring gear is going to actually dip into the bath of oil and then carry that oil across the top side and then dump it back out. And so the lubrication systems are fairly simple on most of these axles. They simply just require adequate, good oil that's not dirty, and they require adequate volume of oil. So you have to have the proper amount. And one of the ways we check for the proper amount is by simply taking the fill plug out of the top side of the differential and reaching our finger down inside there. And most manufacturers have a spec that says somewhere around a ½ inch below the fill line is where you should have the fluid level be. Pay attention to the fill procedures, because some of these manufacturers design these axles and they're very, very sensitive to overfilling. And so if you think about what happens if you overfill, you have a tube that runs out to the driver's side and the passenger side from this case right here, and there's a seal out there. And so if you have too much oil in the case, you could end up with a situation where you start to have axle seals that leak. And so some manufacturers, I've seen it, General Motors has a front differential, for example. There's a technical service bulletin out for it that says that by overfilling, and by overfilling what they mean is coming all the way up to that actual fill port. And so if you fill it up until it just kind of barely dribbled out, it's overfilled. It needs to be 1/2 inch below the fill mark. And if you go all the way up to the top, you will cause a customer concern of oil leak coming from, I think it's the driver's side axle seal. It's not even the passenger side axle seal that leaks in that case. And so pay attention to the fill levels and make sure that you're using the correct fluid. The correct fluid is going to be found in service information, and if there's any additive packages that need to be dumped in there with the oil, you need to pay attention to that as well, so that way you don't cause a limited slip burn-up situation because you did not add a proper friction modifier to that fluid. If you buy OEM-specific part number fluid, it'll contain any additives that are supposed to be in there. If you are using a generic 80-90 weight oil, for example, and they also call for an additive package, you must buy that additive package and dump that into the case as well to make sure that you are following manufacturer procedures. Some of the procedures that you can do in the shop on chassis with the axle installed in the car are internal backlash checks, axle shaft end plate checks, axle flange runout checks, leak inspections, and limited slip differential inspections. And so in the chapter, it goes through a few of the procedures here. If we look at illustration 13-10, this would be an axle shaft end play check, where you can literally push the axle in and out and check and make sure that you have proper end play. If you had an internal clip issue that holds all that together and maybe the clip is a little bit worn, you might have an axle that literally pops in and out. That would cause a seal issue. It can also cause brake issues. If you have a customer that's taking the vehicle off-roading, maybe they've overloaded the vehicle. You see this a lot on pickup trucks. They put too much weight in the bed. They put too big of a trailer hooked up, and then they go hit some big bumps. And what happens is the axle shaft itself will bend. And so in this illustration here, we're checking the axle tube, but we're not checking the axle tube. Excuse me. We're not measuring the axle tube, we're measuring out at the flange for any type of walking that's happening. And so if we have an axle shaft that's bent, you'll see that bend in a wobble out on the wheel side. And so if you have a customer that's complaining of maybe like a vibration issue or a shake issue, or maybe they're just chewing up brake pads because they have a disc brake rotor in the back, you can spin that wheel, and sometimes you can visually see it, but if it's not really bad, you might have to put a dial indicator on it. Regardless, if you're going to replace an axle, you should set up a dial indicator just to make sure that you're documenting the exact amount of run out, and so that way when you put the new axle in, you can take another measurement and you can see the improvement between the old and the new. Leaks are pretty straightforward on differentials. There's not a whole lot of locations where they're gonna leak out at. Typically, the most common are going to be the pinion seal, so that's right on the back side of the drive shaft. The outboard axle seals, they like to leak. The differential cover likes to leak, depending on when the last person did a service. If they used RTV instead of the gasket, did they clean all the old junk off? Did they tighten the bolts down all the way? But there's one other location that leaks that people don't think about, and that's where the axle tube actually comes into the case itself. And so that's a press fit in most cases. And I have seen where that axle tube has become pitted and rusted, and there's a little bit of oozing that comes out. There's not a whole lot you can do for that other than disassemble and seal it with some sort of RTV as you push the two halves back together. There's no O-ring in there. There's no seal from the factory. It's just a friction fit. But over time, with a really old axle assembly, you might end up with rust and pitting that water gets down in there, oil starts to come back out. And so don't overlook this little area right in here where the two axle halves, the axle tube comes into the actual case itself. Checking for limited slip functionality to see if the clutch packs are good. You can utilize a torque wrench. There are procedures that you can look up in service information. Service information is going to give you a torque spec, and so what you're going to do is you're going to plant one tire. So this is an axle, so there's another wheel on the other side of this. You're going to put that on the ground. You're going to have this side elevated, and you're going to literally put a torque wrench with a beam style torque wrench, something that you can actually measure rotational force with, and you're going to rotate that axle, and you're going to be measuring the amount of friction that's in that limited slip clutch pack. And too low means that the thing is burnt up, too high means that it's partially engaged. And so service information will give you the procedure for that. It's fairly straightforward. Usually you're talking like 35, as the book says, 35 to 40 foot-pounds of rotational force. Above is bad, below is bad, and if you find something outside of that, depending on what the customer concern is, you're going to be tearing down the axle at that point to replace those components. And then, you know, again, that could have been done because you could have had damage because somebody did not use the proper friction modifiers the last time it was serviced, or maybe the customer just really drives the vehicle hard, they hot rod it, and they've burnt up the limited slip components. One very crude method for determining backlash without doing anything other than just putting the vehicle up in the air is illustrated on figure 13-7. So in red we have a drive shaft, in green we have a differential. One of the things you can do is simply put the transmission in neutral and wiggle that drive shaft. Try to rotate it one direction and then try to rotate it another direction. And if you have a bunch of backlash, what you're going to notice is that axle, that drive shaft is going to rotate excessively. Okay, now on to tear down and rebuilding of a differential. This part's going to be a little difficult for me to explain, so I'm just going to hit on some I'm going to hit on some specific topics, and then I'm going to have you guys watch the videos, because the videos that I have are done with actual components. But something to keep in mind, anytime you tear down an axle, before you just blow the whole thing up into little tiny pieces on your bench, you want to be mindful of finding the smoking gun. And so what I mean by that is something is obviously broken, and that's why you're tearing down the axle. It's always a good idea to take a report as you're tearing down a component and actually do a disassembly inspection procedure. And so it's not 100% necessary, but it does give you some peace of mind. So when you're tearing down the axle, what I'm talking about here is checking things like rotational force on a pinion gear. So we can actually check the preload of the pinion bearings. You can see if they're worn out. You could check for backlash. You can have an inspection on seals, seal shafts. So is the surface area that the new seal is going to ride on, is it adequate, or are we going to have to replace a component before we put it back together? Be mindful of the teardown procedure. You want to be looking for any problems as you're going. You don't want to just tear down the axle and have a big pile of parts. Something else to pay attention to. In these axles, a lot of times there are shims, and so this illustration is not the greatest, but it's one of the best ones in here. In order to set the preload on your bearings for your actual carrier assembly, there's a shim pack on this side and there's a shim pack on the other side. Those shim packs can be adjusted. You can go up and down in thickness by like 0.010 of an inch increments. And what that's going to do is it's literally going to move this ring gear closer to the pinion gear or further away from the pinion gear. And if you keep track of the old shims before you tear this thing down, and you pay attention to how many shims came out of the passenger side, how many shims came out of the driver's side, you can use it as a reference when you go to reinstall the new components. And so it'll help you get set up faster, because checking gear backlash and checking contact pattern is critical. And in order to send an axle out, you have to have all those tolerances in spec. And so if we get into page 246, this is what I'm talking about. So the contact pattern between the heel and the toe has to be correct. You can't be too far off on an edge. You can't be too tight into the middle. You have to be kind of like right here, right in the center portion of the gear. You want to be about 50% in the middle and 50% up and down. And one of the only ways to really adjust that gear contact pattern is by moving the pinion gear inboard, like changing shims and dropping the pinion gear deeper or shallower into the case. And then you can also set the ring gear left to right with shim packs. And so if you pay attention to the shim packs and where they came out in the first place, and you put them back in the same place that they came out, 9 out of 10 times you're going to have a contact pattern that is correct the first time. If you have to make any modifications, you're going to have to tear the entire axle back apart, pull bearings back off, and a lot of times these bearings are one and done, and so if you press fit them on, you'll destroy the cage by pulling them back off to get to a shim, to change a shim, and so you can end up going through lots of bearings and causing lots of headache and frustration. But there are a few tricks, and in the videos, those tricks are going to be illustrated for you. Something else that rebuilders will do, people that do a lot of rebuilding, if we take a look right here, this is a pinion gear. This pinion gear has a shim right here, okay? So what I'm talking about, that this bearing has to be pressed up to this pinion gear, but there's a shim in place. And so if I have my contact pattern is incorrect, I'm going to have to pull that bearing back off. And if I can't get behind the bearing in order to catch the center portion of the bearing, I'm going to end up breaking that bearing. And so one of the tricks that rebuilders will do is they'll have a extra set of bearings. And now I don't mean you have to go buy like a second set necessarily every time you rebuild an axle, but let's say you do a lot of rebuilding and you do a lot of the same type of axles over and over and over again. a good idea is to take this bearing, so have a new bearing, and then literally take a Dremel to the center of the bearing and wallow it out and remove the press fit. So that way this bearing simply slides over that shaft. And what you're going to do is, for the pinion bearings and also for the carrier bearings, you're going to cause them to not have a press fit, which is going to be just for setup only. And then what you'll do is you'll set up the differential with all these bearings in place, and then you'll check your contact pattern. And if you're happy with the contact pattern, you'll take it all back apart one more time and put the actual new bearings press fit onto the shaft. If you're not happy and you have to change out shims, it's not a big deal, because you just disassemble, slide the bearing off, change the shim pack, slide the bearing back on, and recheck your contact pattern.